Hello everyone and welcome to IP Study Lecture video. Today I'm going to take chapter number 11 of grade 7 and the name of the chapter is Symmetry. So let's see what are the topics that we are going to cover in this lecture. So first of all, we will be discussing about what is symmetry. Then we will be discussing about line of symmetry for different shapes and objects. Thereafter, we will be discussing about rotational symmetry. So without wasting our time, let's start the lecture. So dear students, this topic, symmetry, is quite familiar to us because we have learned about this topic in our previous grade as well. So let's recall that same. So here, what is symmetry? A figure that is identical on both sides of a line is called symmetrical figure. And the line about which the object is symmetrical is called line of symmetry. So in order to check whether a given figure is symmetrical or not, fold it on the central line. So in order to understand this, let's take some example. Suppose you have given a picture of flower over here. If I draw a dotted line at the center, if I fold it, then what I will see? I will see the left part is exactly same or identical to the right side, right? So in this case, I can say this is symmetrical. Similarly, let's take an example of a leaf over here. So if I draw a dotted line over here or say a line of symmetry, these two parts are totally identical or look similar to each other. Hence, I can say that this leaf is also symmetrical, right? Now, there are certain objects that doesn't look alike. They don't look the same. In that case, we call these type of object asymmetrical. So here two examples are given. One is tortoise and another one is a car. So here I can see if I draw this dotted line over here as a line of symmetry, I cannot see any identical part over here. Means the first part is not identical to the second one. So here this is not symmetrical, this is asymmetrical. Similarly, this figure is also asymmetrical. So I hope you have understood the meaning of symmetry and the difference between symmetrical and asymmetrical shape. Now, let me take some more examples for you. In the previous grade, we have learned about the lines of symmetry can be vertical and horizontal. There are some objects, some alphabets having vertical line of symmetry or horizontal line of symmetry, and there are some objects or shapes that have both the line of symmetry in them. So let's discuss some of the examples over here. Let me take an example of, say, letter A. Okay, let me write it over here for you. I have this letter A with me. Now, if I draw a line like this, line of symmetry, I can see the two parts, the left part and the right parts are identical to each other. So I can say alphabet A is symmetrical, right? So here for this alphabet A, we have vertical line of symmetry, right? Now, let me take another example for you. Let's say we have letter B. So here in this case, in this case of letter B, if I draw a line of symmetry, let's say like this, can you say that the upper part is identical to the lower part? Yes. So I can say alphabet P is symmetrical and it is symmetrical about horizontal line of symmetry, right? So we have horizontal line of symmetry for alphabet B and we have vertical line of symmetry for alphabet A. Now let's talk about an alphabet that has both vertical line of symmetry as well as horizontal line of symmetry. And what letter is there? We have letter X. Okay, so letter X have both the line of symmetry, vertical line of symmetry as well as horizontal line of symmetry. If I draw this line over here, I can see the upper part is identical to the lower part. It means letter X is symmetrical about horizontal line of symmetry. Similarly, if I draw a vertical line like this, still I can say that the left part, this one, is identical to the right part. So what does it mean? It means that letter X is symmetrical about vertical line of symmetry as well as horizontal line of symmetry. So I hope you have understood these topics. I hope you have understood these examples as well. Now, let's move on to the next topic, and the next topic is lines of symmetry for regular polygons. So what are regular polygons? So dear student, we have already discussed about regular polygons in our previous grade, right? So what are regular polygons? Regular polygons are the polygons having equal sides and equal angles, right? The smallest regular polygon is equilateral triangle because it has 3 equal sides and it has 3 equal angles. So let's see the line of symmetry for equilateral triangle. So here you can see an equilateral triangle is drawn over here, right? Now, let's draw a line of symmetry for this equilateral triangle. Let me draw from this vertex to this line. So, I can see this part, the left part is identical to the right part, right? Now, let me draw another. Now, let me draw a line of symmetry from this vertex. Again, I can see this part is identical to this part, right? Now, let me take another color. Let me take the yellow one and draw another line of symmetry from this vertex. Again, I can see this part is identical to this part. So here I can see I have drawn 3 lines of symmetry over here and the equilateral triangle is symmetrical about these 3 lines of symmetry, right? Now, let's take another example. Let's take example of a square. So how many sides we have in a square? We have 4 equal sides. And how many angles we have? We have 4 angles and each angle is of 90 degree. It means that square is a regular polygon, right? Now, if I want to draw lines of symmetry for the square, so from where I can draw? 2 lines of symmetry can be drawn from the diagonal side. So I have these 2 lines of symmetry, right? And another line of symmetry can be drawn from the point joining the midpoint, right here, these 2. So how many lines of symmetry I got for this square? I got 4 lines of symmetry, 1, 2, 3 and 4, right? Similarly, if I talk about pentagon, in pentagon we have 5 sides, right? And we have 5 equal angles. And if you draw a line of symmetry, how many lines of symmetry can be drawn from this pentagon? We can draw 5 lines of symmetry for this, 1 from each vertex, right? So dear student, if you talk about hexagon, in this case we have 6 lines of symmetry. So after discussing line of symmetry for this regular polygon, we come to know that, we come to the conclusion that a regular polygon has as many lines of symmetry as the number of sides it has. If we are talking about the equilateral triangle, it has 3 equal sides. It means it has 3 symmetrical lines or line of symmetry. If we are talking about square, in square we have 4 equal sides. It means it has 4 lines of symmetry. In case of pentagon, since we have 5 equal sides, we will be having 5 lines of symmetry. Similarly, for hexagon, we will be having 6 lines of symmetry like this. Okay, so I hope you have understood this topic very well. Now let's move on to the next topic. The next topic is reflection. So the concept of line of symmetry is closely related to the mirror reflection. So for example, suppose I have drawn this angle over here and I put a mirror over here which will act as a line of symmetry for me. So the mirror image of this will come out like this here, right? So what we have concluded from this example, we can see the image is equally distant. The image and the object are equally distant from this line of symmetry and they are of the same size, right? So it means that if I put a mirror over here and if you see the reflection of this image of this object, if you see the reflection of this object over here, you will find that the 2 are totally identical of each other, or you can say that it is symmetrical, right? So that is why we are saying the concept of symmetry is closely related to the mirror reflection, right? Now, let's move on to the next topic. So the next topic is rotational symmetry. So dear student, we have just finished a discussion about what is symmetry and about line of symmetry. Now, rotational symmetry is quite different. How it is different? So let me tell you. So a figure is said to have rotational symmetry if it looks exactly the same when it is rotated. And the next thing is, the point about which the figure is rotated is called the center of rotation. Here, in order to understand this, let's take an example. You can see a triangle is drawn over here with points, let's say point A, B and C, right? And this triangle is going to be rotated about this point. So this point is called center of rotation, okay? This point is called center of rotation. Why? Because I'm going to rotate this triangle about this point only. Now I've started rotating this shape, this triangle. I've rotated first by 90 degree. It looked like this. The position of A now comes here, right? Now this triangle is not exactly the same, the triangles I was having it, right? Now again I will rotate this triangle. When I rotate this triangle by 90 degree, again I can see the position of A is here. Again, this triangle is not looking like this triangle, the triangle I was having initially, right? Now, again I will rotate this triangle by 90 degree. Then the position of A will come here. Again, I can see this triangle is not looking exactly the triangle I was having initially, right? Now, if I again rotate this triangle, I will have this triangle and this triangle and this triangle are looking alike, right? Now, there are certain terms that we need to take care of while dealing with rotational symmetry. So, first thing is angle of rotation. What is that? The shortest or the smallest angle with which you are going to rotate an object so that it looks exactly the same to its original one. We called it angle of rotation. The condition is that it has to look exactly the same within a full turn. Okay. Next term is order of rotation. Order of rotation of any object. Okay. Order of rotational symmetry. So what does it mean? When you are rotating an object about its center of rotation with some angle, and you have to note down after how many times that object look exactly the same to its original position. That number is called order of rotational symmetry. Now, there is a relation between the order of symmetry and the angle of rotation. In order to find out order of symmetry, what you can do, since we are checking for a full turn, right? So we can divide 360 degree by the smallest angle, means the angle of rotation. If you do so, you will get your order of symmetry for that particular shape or particular objects. Now, in order to understand this, let's take an example of a rectangle over here, right? So whatever we have discussed about rotational symmetry, we have discussed about center of rotation, we have discussed about angle of rotation, we have discussed about order of rotational symmetry. So all these we are going to cover with this example. So carefully look at this example. Here you can see a rectangle is there, right? When you rotate this rectangle by 90 degree, it will look like this. So it is not looking like exactly the shape I was having initially. Now again, this rectangle is rotated by 90 degree. So I can see now this is similar to this one, right? It means after 180 degree, I can see my rectangle back to its original position, right? So what is the minimum angle? Minimum angle is 180 degree, because if I rotate it further by 90 degree, it will not look alike. But if I further rotate it by 90 degree, that means if I rotate it by 360 degree, I'll get the same rectangle back to me. So after 180 degree or at 180 degree or at 360 degree, I will have the similar shape, right? So here, what is my minimum angle? Minimum angle become 180 degree. That will become an angle of rotation. Now, in order to find out order of rotation, what I will do, I will divide 360 degree by 180 degree, because this is the minimum angle at which I get the same shape, right? So if I do so, what I will get 2. So if I ask you what is the order of rotation for a rectangle, then your answer will be 2. And I've shown you how to, and it is shown over here how to find out order of symmetry for this rectangle, the examples we have taken over here. So I hope you have understood this example very well. Now let's take one more example to understand this topic more clearly. Suppose I'm taking an example of a square over here. So where will be my center of rotation? So the point of intersection of these two diagonals will become center of rotation for me, right? Center of rotation. Now I will start rotating this square about this point. Okay, this will become center of rotation for me. So this is my square. I rotate it by 90 degree. I'll get the same square. Again, I'll rotate it by 90 degree. I'll get same square. Again, rotate by 90 degree. The square will be same, right? Again, I'll rotate it by 90 degree. I'll get the same square. So here, I have rotated this square 4 times, right? And in all the cases, I can see I'm getting the same square, right? So here, how many times I have rotated this square? 4 times. So what is the order of symmetry for this square for me? It is 4. And what is the angle of rotation? The minimum angle at which I am rotating this square so that it looks exactly the same to its original one is 90 degree. So angle of rotation for this square will be 90 degree and order of rotation will be 4. And center of rotation will be the point of intersection of these two diagonals. So I hope this concept is clear to you. Now let's move on to the next topic. So the next topic is figures having reflection and rotational symmetries. So I have taken good examples in this chapter only previously. So let me tell you one thing. There are many objects, many shapes, many alphabets which have the reflection symmetry as well as rotational symmetry. So now let me take an example for you. Let me show what are the object, what are the alphabets over there. So here let's take an example of alphabet I. So I know that if I ask you, does I have a rotational symmetry or reflection symmetry or both the symmetry, then you have to check out, right? So here I have drawn I. Now let me draw a line over here. Can I say this part is symmetrical to this part? Yes. So I can say alphabet I has horizontal line of symmetry, right? Now let me take another one, another color. Now suppose I am drawing a line over here, vertical line. So can I say this part is identical to this one? Yes. So this side is identical to this side. So yes, I has vertical line of symmetry. So how many line of symmetry we have for I? We have 2 lines of symmetry, right? Now, if I ask you how many rotational symmetry we have, what is the order of rotational symmetry for I? Then you have to check. So as we have just discussed 2 examples over here, let's try for I over here. Let's draw I. If I rotate this I by 90 degree, how this I look like? It will look like this. It will look like this, right? Is it similar to the one that we have initially? No. Then again I will rotate it by 90 degree. Then how it look like? It will look like this. It means that after 180 degree we will have I back to its position. Similarly 360 degree we will have I back to its position or similar to its position, right? So what is the minimum angle over here? Minimum angle at which I look exactly the same to its original position, it is 180 degree. So according to that, what will be the order of symmetry for I? We have to check out. So simply divide 360 degree by 180 degree, it comes out to be 2. It means that for I, we have 2 as order of rotational symmetry. So my question was, does I have rotational as well as reflection symmetry or has only one? Any one of them? So the answer is I has both. Alphabet I has rotational symmetry as well as reflection symmetry, right? So we have discussed here what is symmetry. We have discussed about lines of symmetry. We have discussed about different alphabets or different objects having both the line of symmetry, right? Then we have discussed about line of symmetry for regular shapes, right? And we come to know that the number of sides of a regular shapes is equals to the number of line of symmetry in it. Then we discuss about rotational symmetry, we discuss about center of rotation in it, we discuss about angle of rotation, we discuss about order of rotation, and we took some example as well in order to understand that topic in a better way. And then we saw there are some alphabets as well having both reflection symmetry as well as order of symmetry. So that's all for this lecture. We will meet you soon in the next lecture. Till then, take good care of yourself, keep smiling, keep practicing, keep learning.